Here's the video that involves wavefronts. So here we've got a ray of light that's about to hit this mirror, and we're supposed to draw in the rest of the ray diagram and the wavefronts. So as we know, rays of light are supposed to move in a straight line, and then when they reflect, they reflect in such a manner that the angle of incidence, this right there is the angle of incidence, should equal the angle of reflection. And remember, it's always important for us to draw our perpendicular, or what we call our normal line. These are the wavefronts. The wavefronts show the distance between two wave crests, two consecutive wave crests, or two wavelengths. Okay, so there they go. And then they would also be drawn on the reflected ray as well. All right, so here is a ray, here are a set of wavefronts that they've drawn in for us. They want us to draw the reflected and the incident ray. So since these are wave fronts that are reflecting off of this mirror, our ray diagram must go perpendicular away from the mirror. So here are the wave fronts that correspond to this ray, to this reflected ray. These little arrowheads are showing the direction of the wave fronts, and there's our normal line. Then here's the incident ray coming in, and we need to also draw its wave fronts. And so there go their wave fronts and the arrowheads that go along with them. Okay, so here's a setup where they're showing us wavefronts going from a medium where the wave is slow, and here where the wave is faster. So as we know, where it's slower, we've got a higher index of refraction, and where it's faster, we've got a lower index of refraction. So we draw in our incident ray. We draw the normal line perpendicular to the surface where the ray hits the interface. Then we know when we go from a higher to a lower index of refraction, the ray of light bends away from the normal line. In this case, our wavefronts would respond or react to that. Okay, again, they're perpendicular to our ray, and they're set a certain distance apart. Notice the distance between these two wavefronts is greater than the distance between these two wavefronts. Okay, and then we also draw in the arrowheads showing the direction of the wavefronts.